Stay Grubionama children, welcome to online class.
Today's topics complex numbers and quadratic equation. Before we are going to start the complex number, we are going to recall what are the types of numbers we learned in earlier classes. First one, natural numbers. The natural numbers starts from 1, 2, 3, 4 up to etc. Next one, whole numbers. Whole numbers is start from 0, 1, 2, 3, 4 up to etc. Next one, integers. Integers becomes negative number with whole numbers. It is called a integers. Next is rational numbers. Rational number can be expressed as P by Q form where P, Q are integers, Q not equal to 0. For example, 2. 2 can represent as 2 by 1. It is in the form of P by Q. Then next one, square root of 4. Square root of 4 can be plus or minus 2. This also represent as 2 by 1. Next 5 by 2. If you are converting into a decimal, we will get 2.5. It is a terminating function. Then next one by 3. 1 by 3 if you are converting into a decimal 0.3333 up to etc. So it's a non-terminating repeating. So we are not getting the remainder 0 at the same time. Repetition is also coming, but it is in the form of P by Q. Next one, irrational numbers. So what is meant by irrational number? It cannot be expressed as P by Q form. It is a non-terminating, non-repeating. For example, square root of 2. 1.414212 up to etc. So we are not getting the remainder 0 at the same time. Repetition is also not coming. No pattern is there. It is a irrational number. So real numbers. What is my real number? Is a collection of all these numbers. That is rational, irrational, integers, whole, natural. It's called a real numbers. Real number is a huge collection of numbers. Next one, quadratic equation. So what is the general form of quadratic equation? Ax square plus bx plus c equal to 0, where a not equal to 0, a, b, c are real numbers. You know this one. From then this quadratic equation, how can you find out the roots of this equation? By using quadratic formula. X is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here b square minus 4ac is called discriminant values. What are the properties of the discriminant? If d greater than 0, the roots are real and unequal. If d equal to 0, the roots are real and equal. If d is less than 0, roots are imaginary. This imaginary value we can't represent using a real number system. Using the real number system, we can solve the quadratic equation. But all the quadratic equation cannot be solved. The discriminant value less than 0, that roots are imaginary. To find the value of this imaginary, that one number system, that is called complex number. So what is the standard form of complex number? Z equal to a plus ib, where a, b are real numbers. Here a represents real part and b represents imaginary part. For example, x square minus 9 equal to 0. This is one of the quadratic equation. So how can find out the roots of this equation? X squared equal to 9. Therefore, x is equal to square root of 9. This is square root of 9 plus or minus 3. Therefore, x is equal to plus or minus 3. We got answers. Then same one, if x square plus 9 equal to 0. How can you find the roots of this equation? So x square equal to minus 9. So we have to find out x. So x is equal to square root of minus 9. We know that square root of 9 only is a perfect square. But here square root of minus 9 is there. So I am going to write square root of 9 into square root of minus 1. What is square root of 9? That is plus or minus 3. Into what is square root of minus 1? The square root of minus 1 is denoted I. So it is I. Therefore, plus or minus 3i. So here we are getting a imaginary values here. So x is equal to plus or minus 3i. So it can be written as x is equal to 0 plus or minus 3i. So we are getting a complex number. What is 0 here? This is one of the real values. So 0 plus or minus 3i. 0 is a real part, 3 is a imaginary part here. So what is the square root of 1? That is equal to for I. Then if you are taking squaring on both sides, I square is equal to minus 1. Therefore, I square values is also equal to minus 1. So this is the standard form of the complex number is z is equal to a plus ib, where a, b are real numbers. Here a represents real part, b represents imaginary parts. Exercise 5.1. Express each of the complex number in the form of a plus ib. So here what the question is given? 5i into minus 3 by 5 into I. So here 5i into minus 3 by 5 into I. Here I can cancel 5. I into I square. 1 into minus 3, minus 3. We know that value I square is minus 1, which is equal to minus 1 into minus 3. That is equal to 1 3 is 3, minus into minus plus. So we are getting a plus ib forward because we are getting only real part. Imaginary part is 0 here. Next question, I power 9 plus I power 19. So I power 9 can be written as I square the whole power 4 because 9 2 4s are 8, but here I power 9 is there, so one more I am writing here. Next one, I power 19. We know that value I square value only. So that format I am writing I square into the whole power 9. 9 twos are 18. So, but here 19 is there. So, one more I. So, I square values is minus 1. The whole power 4 into I. Plus, I square values is minus 1. The whole power 9 into I. Which is equal to minus 1. The whole power 4. Power is even. You will get only positive values. So, 1 into I. Here minus 1 the whole power 9. Power is on means you will get negative values. So minus 1 into I minus I. See here minus I plus I cancel. You are getting 0. See here real part is 0. Imaginary part is also 0. Next I power minus 39. So I power minus 39 can be written as I square into the whole power minus 19. So 2 into minus 19 minus 38. But here minus 39 is there. So I am writing one more I power minus 1. I square values is minus 1 the whole power minus 19. So I power minus 1. You can read inverse also. It can be written as minus 1 by 1 power 19 into it can be written as 1 by I minus 1, 1 power 19, 1 only into 1 by I. So answer minus 1 by I. But the denominator I is there. So I am doing the conjugate. So I by I am multiplying the numerator and denominator. That is equal to 1 into I minus 1 into I minus I by I into I square. I square values is minus 1. So minus minus will cancel, that is equal to for I. Here we are getting only imaginary part. Real part is 0. Second Roman letter. Find the multiplicative inverse of each of the complex number given below. So 11th one. 4 minus 3i it is given. But they ask find the multiplicative inverse of this one. What is the multiplicative inverse? That is z inverse. But question 4 minus 3i is given. So I am going to take let z equal to 4 minus 3i. But they ask z inverse. So z inverse means that is equal to what? 1 by z. See here z is what is here? 4 minus 3i. So 1 by z equal to 1 by 4 minus 3i. So in denominator we have to rationalize. So here I am going to multiply the numerator denominator 4 plus 3i by 4 plus 3i. So which is equal to 1 into 4 4, 1 into 3i 3i. But the denominator, it is in the form of a plus b into a minus b. Instead of a place is 4 is there, b place is 3i is there. So, a plus b into a minus b, a square minus b square, that formula, which is equal to 4 plus 3i by 4 square is 16 minus 3 square is 9. I square values is, we know that one, minus 1. Then 4 plus 3i by 16 minus into minus plus. So plus 9. Then 4 plus 3i by 25. So this is the multiplicity inverse of 4 minus 3i is 4 plus 3i by 25. Can be written as 4 by 25 plus 3i by 25 also. Is that inverse equal to this answer? So next question, 12th question. Root 5 plus 3i. So 12th one. So let us you take z is equal to root 5 plus 3i. So they ask z inverse. So you should take 1 by z equal to 1 by root 5 plus 3i. We have to conjugate that one. So root 5 minus 3i by root 5 minus 3i. That is equal to 1 into root 5 minus 1 into minus 3i minus 3i by the denominator a plus b into a minus b. So we know that identity a plus b into a minus b, a square minus b square. So next step, so root 5 minus 3i by 5, root 5 square, that is equal to 5 minus 3 square is 9 and I square is minus 1, which is equal to square root of 5 minus 3i by 5 minus into minus plus 1 9s are 9. Then square root of 5 minus 3i by 14. So z inverse equal to root 5 minus 3i by 14. So we have to take the answer and write it root 5 by 14 minus 3i by 14. Next one, 13th one. Minus I they ask. Minus I. 13th one, minus I. So first you take z equal to minus I. But question z inverse we have to find. Z inverse is 1 by z. So 1 by z equal to 1 by minus I. So we have to assess the denominator. So I am going to multiply the numerator denominator I by I. That is equal to 1 into I square into I into I square. I square values is minus 1. Minus of minus plus 1. Therefore, that answer is I. So, Z inverse is equal to I. Sum number 14. Express the following expression in the form of A plus IB. So, what the expression is given here? 3 plus I root 5, 3 minus I root 5 by square root of 3 plus I square root of 2 minus of square root of 3 minus I square root of 2. First, we have to simplify these expressions. So, 3 plus I root 5 into 3 minus I root 5 by the denominator square root of 3 plus I square root of 2 into here minus of square root of 3 minus I root 2. So in numerator it is in the form of a plus b into a minus b. We know the identity a plus b into a minus b, that is equal to for a square minus b square. Instead of a places here 3 is there, so 3 square. Instead of b places I root 5 the whole square. By denominator we have to remove the bracket. So square root of 3 plus I square root of 2 minus square root of 3 minus of minus plus I square root of 2. So here my plus minus root 3 plus root 3 will cancel. In numerator 3 square is 9 minus you have to take the square inside. So I square root 5 the whole square that is equal to for 5 by I root 2 that is equal to for 2 times of root 2 I. Then which is equal to 9 minus we know that value I square is minus 1 minus of minus plus so 5 by 2 root 2 I then 9 plus 5 that is equal to for 14 by 2 root 2 I so by using two tables 7 times will come 7 by square root of 2I we have to do the conjugate here so you multiply the numerator and denominator root 2I by root 2I that is equal to for 7 root 2I by root 2 into root 2 2. I square is minus 1. So minus 2. Therefore the answer 7 root 2I by minus 2.